In this video, we're going to review a couple basic derivative rules. So if you have the derivative of a constant, that could be a nice whole number constant like 10. It could be something with a pi in it, like 4 pi. Maybe it's e to a number. You could type in e squared on your calculator. That is just a number. Or if it was ln of a constant. If there's no x, there's no variable in this, you could type this entire thing into your calculator right now. 10 plus 4 pi plus e squared plus ln of 2. These are all just constants. They all have a derivative of 0. So if the original function is just a constant, the derivative is 0. To make it a little more interesting, we could have x to a power. That means when we take the derivative, we are going to bring down the power and subtract 1 for the new power. So if we had x to the 8th minus x to the 4th plus 3x, the derivative of x to the 8th, we get to bring down the power and subtract 1 for the new power. So we'd bring down 8x to the 7. We'd keep that minus sign and bring down the 4 and raise x to the 3. Bring down the power, subtract 1 for the new power. And then if you have a constant times x, it's just going to be that constant. Because you bring down the power 1, 3 times 1 is going to say 3, and then x is 0. We wouldn't typically write. We can make it a little bit more complicated. But first, just doing another one of those examples. X to the 10th plus 2x minus 3. X to the 10th, we're just going to bring down that power 10 and subtract 1 for 9. Derivative of 2x is 2. It's a number in front of x. So we bring down the 1 power, 2 times 1 is going to stay 2, and then we have x is 0, which is just 1. And then the derivative of negative 3, that's a constant. The derivative is 0. So now to make it a little bit more difficult, if we had x to the 4 over x to the 3rd minus 1 over x, something like that. We have x's to a power, but it's in the denominator, so the power is not written nicely for us. We're going to need to take a second and rewrite the original function. This is 4x to the negative 3 if we want to pull it out of the denominator. And then we have minus 1, and we're going to bring the x out of the denominator to a negative 1 power. If it's in the denominator, it's a negative power. That was not the derivative that we took, since we did not bring the power down and subtract 1 for the new power, but now we're ready to. 4 times negative 3 is going to give us negative 12. X to the negative 3 minus 1 is negative 4. Bring down their power again. Negative 1 times negative 1 is going to be a positive 1. And then we have x to the negative 1 minus 1 is negative 2. Continuing to make that algebra a little bit more difficult, maybe I'll call it f of x this time. If we had the square root of x plus 2 over x to the 5th. Well, we'd start by just saying, well, that original function is really x, square root means 1/2 power, plus 2x in the denominator means it's a negative power. So square root is 1/2, third root is 1/3, fourth root is 1/4, fifth root is 1/5. So just remembering from algebra how to rewrite those roots as fractions. And then anything in the denominator is truly a negative power. Those aren't the derivatives because we did not bring down the power and subtract 1 for the new power. All we did was rewrite. But now we're ready to take the derivative 1/2. X to the 1/2 minus 1. Subtract 1 for the new power, you get negative 1/2. Same thing here. 2 times negative 5 is going to be negative 10. Negative 5 minus 1 is negative 6. So the calculus is always bringing down the power and subtracting 1 for the new power when you have x to a power. The algebra can make it a little bit trickier because you might have to rewrite before you can take the derivative. So just continuing with some more tough examples. Let's say we have the 5th root of x to the 3rd plus 5 over x to the 10th plus 2x minus 1. First of all, we have to rewrite this, so I'm still going to call it g of x, not g prime. I'm not ready to take the derivative yet. This is x to the power of a root. This is 3 over 5. plus 5x to it's really a negative 10 if we're taking it out of the denominator. And then that plus 2x minus 1 looks fine. Now we're ready to take the derivative of the whole thing. Derivative means bring down the power, so 3/5. Subtract 1 for the new power. 3/5 minus 1 is negative 2/5. Same thing with this negative 10. Bring down the power. 5 times negative 10 is negative 50. Subtract 1 for the new power. Negative 10 minus 1 is negative 11. Derivative of 2x is 2. Derivative of negative 1 is just 0. It's a constant. So there's a quick recap of all of our rules and then some super complicated algebra mixed in.